Hi all, and welcome to Elementary Astronomy Lab. I will be your lab professor, Professor Hamilton, and I'm coming to you from sunny California. I have a summer job as a camp instructor, so like a summer camp instructor, and I will be in California for the whole time almost the whole time I am teaching you. So if you have any questions, just let me know, email me, and that would be the best way to reach me. However, it may be 24 hours before I get back to you, at least 24 to 48 hours, just because we're so busy up here at summer camp. Anyway, let's go ahead and go over how to do Canvas, how to navigate it, at least this class, and then we'll start on how to do the lab, because you have one lab due this week. Usually it'll be 2 labs, but for this week, we're just going to start out with something simple and not overload you too much. All right, so let's get started. I'm going to share the screen. All right, so when you go and click on the dashboard icon for Elementary Astronomy Lab, I made a little picture. So you should have that. You should see that whenever you click it. This will be the first page that pops up. This is the home page. What you want to do the first time you come into this Canvas page is click the Start Here button. That's where you start, okay? It's there for a reason. So we want to make sure that we go there the very first thing. And it's basically just kind of my background a little bit. Before you start and do anything, I would love for you to read my introduction letter. It will tell you a lot about me, and it'll help kind of make sense if I'm a little weird or a little absent-minded, because I do have ADHD and OCD, and I am neurodivergent. So that is super important for you to read, because I might do things that may be a little weird, maybe you're not used to, but don't fret. So just go ahead and read that. This is a picture of me and my husband. We're cute. This is my email. So if you have any questions, make sure that you send it through the email. You can send it through Canvas inbox if you choose, but they would really rather you, the school would rather have you send your questions through the email, Howard email. This is my phone number. If you have any questions or need something right away, text me and I will get that before I read my emails. Cool. I'm not probably going to have office hours unless it's really, really, really needed, just because camp is so, we're doing stuff all day long. And so it's a lot harder for me to take time out, like an hour or two, to give you one-on-one stuff. So like I said, if you have any questions, just email me. You're going to read the syllabus, which we'll get there in a second. The textbook is this. Oh, and I didn't link it. However, if you just go to the lecture page, it's the same book. So that we share the same book. So just use that for Dr. Teeling. He'll get you the right book. You will need lab materials. So you're going to need cardboard. I recommend using Amazon boxes because everybody buys Amazon. You need to have tape, a ruler. And if you don't have a ruler, if you have a phone, you have a ruler. If you have an iPhone specifically, there is a Measure app, and it's one of the pre-downloaded apps when you first get your phone, and it's called Measure. If you deleted it because it's a weird random app that Apple put on there, go back to the App Store and purchase it. The icon looks like this right here, and it says Measure. And test that out. If you need help learning how to use it, there's YouTube. So cool. Don't go out and buy stuff. You will be using materials that you have in your house. If you don't have those materials, you can borrow some from let's say your brother, sister, cousin, husband, wife, mom, dad. Following CDC guidelines, obviously, wear a mask, not like this, to go borrow it. When you get this object, make sure you disinfect it. Just common sense here, people. So let me know if you have absolutely no one that can get you the materials that you need. We may be able to do something. I can contact a couple professors at Howard and we can get you what you need. Cool. This is library link. This is Orientation, you guys should know how to use this stuff though. I'm expecting you to. If you don't, here it is. Technical requirements page, you have to have a working computer. If you don't, Howard Community College has laptops and Wi-Fi routers and like hotspots you can borrow for the semester. So if something doesn't work, call them. It's great. Okay, and then academic integrity and etiquette statement, you can read that later. Okay, next, modules. So what you should see, I'm going to go in student view, is, if it loads, also Wi-Fi is spotty at camp because we're 8,000 feet in the air on a mountain. So also another reason why I may not get the emails right away. All right, so first thing first is the welcome module. You're going to go to the course schedule, and that will tell you everything that we are doing for the semester. So let's go ahead and go there. Make sure that you reference back and see like what we're doing. That way you don't have to ask the question. You already have the resources right here. So week 1, solar system scale. We'll get there in a second. That is due next Wednesday. Today is Wednesday the 2nd. It will be due next Wednesday the 9th. Week 2, we're doing 2 labs. One of them is called measuring circumference of Earth. The second one is called angular size and parallax. So this and symbol right here denotes 2 different labs. If there's something that needs to have like an and is like the part of one lab, I will just put the word and because this is all one lab. Cool. And so you can read this later on. My favorite is building a sundial, but that's the last thing we'll do. Otherwise, week 8 will be observation journals, which I may or may not do that this semester. It's not really something necessarily need to do. But if we do that, I will let you know as soon as I figure that out. I will do a makeup lab, I suppose. It's on here. So I'll only do one though. Usually I drop a lab, I drop your lowest lab, whatever seems to be the best fit for people. Okay, so back to the home page. Well, let's go to modules first. Like I said, internet is super spotty here. You're going to take the office hours quiz and you're going to write the intro discussion assignment. This is the only discussion we'll have to do this semester. I'm not a fan of discussions. I had to do that when I was in college. I think it's silly and it doesn't provide much information, to be honest. So at least for me, my personal opinion, other teachers may use it, whatever. But you need to fill out these 2 things before they're due. I know I said in the announcement that you should have read. This is how I will communicate with you, is through the announcements tab. That's located right here. So if I need to communicate with the whole class as a whole, it will be in an announcement. Make sure that you have the Canvas app downloaded on your phone so that you receive those announcements as they come, as I post them, just like a text message. It's imperative that you do that. If you don't have that option to download it onto your phone, you need to check announcements the very first thing that you do when you come to this page on Canvas. No more interruptions. Okay. You guys can look over this, the discussion assignment. I will post mine soon, hopefully. First thing first is the scale solar system. It's lab 1. But first we're going to actually go back and look at the syllabus because it's important. And the syllabus link is right here, right beside the start here link. Make sure that you read this thoroughly. The late policy is, I think, the most important. So I reiterated it right here. On Wednesdays, when you submit your lab, you must submit at 11:59 or before. If you submit at midnight, it will be counted as late because it's the next day. So you must submit by 11:59. I'd recommend 11:58 if you're really that daring and adventurous. Okay. I will, if you give me a 1 hour notice before the due date saying, hey, I need an extra day or two to finish this lab. I work full time. I do blah, 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 blah. I have 5 kids, blah, blah, blah. Whatever your situation is, I understand. I will give you 2 extra days, 1 or 2 extra days to finish the lab and submit it. But you have to give me at least 1 hour notice before the due date. So 10:59. You must tell me before 10:59 that you need an extension. If you tell me at 11:01, I will not give you that extension because you had the entire week to let me know that you may or may not be late submitting this lab. Just how it goes. If you don't, it will be counted as late whenever you turn it in. And I take off 5 points per day late if lab, or 5% points off per day if you are late. So that out of 20 points, that's 1 point per day late. After 35%, you fail. You fail that assignment, you might as well not turn it in because I will take 1 of the labs off. Cool. If you have a serious occurrence, like COVID or something, you need to let me know. You need to be communicative and tell me that. I can't read your mind. I can't do that. I wish I could. So you need to let me know this, like these things. And we could come up with some sort of compromise. If you are sick and you have COVID, I would like to see your COVID test results. That way that I know that you're not just playing hooky. All right, right here, drop your lowest lab score. Did that. I already said that. You can look at the real syllabus right here at this link on your own time. Cool. Let's go ahead and get started with the lab. This one should be pretty short. It will be the shortest one that you do. The pre-lab, you must do the pre-lab before you start the regular lab. This should not be too hard. It should be like basic algebra, and I expect you to know that. If you have any questions, like I said, just let me know. If not, I'd recommend talking to somebody in your class. You have their emails, I think, on the people's page. Email them or email a couple people. So you're going to go ahead and read through this. The pre-lab, I don't really grade it's too much. So, you know, if you have a serious question about it, that's fine. But really on your own time, you can read this. It's not that difficult to understand. But so it talks about a scale model, scale model of our solar system. It's just going to ask you some very simple questions, and you should definitely be able to do these. How many times larger than Earth does Jupiter appear to be based on the sketch up here? And it's not really a sketch. This is a image, but I did not write this. So, all right. You just say, okay, Earth looks like this size. Jupiter is this size. How many Earths could I fit in Jupiter based on this picture? Only based on this picture. I can't stress that enough. Do not look online. You are using this image right here to tell me. It looks like, let's see, how many Earths in this Jupiter? How many? You do that. That's your answer. Okay, how many times farther from the sun does Jupiter appear to be compared to Earth in the image at the start of this activity? Okay, so how much farther is Jupiter compared to Earth from the sun? That's the question. You can do that easily. And so this is going to be important because these questions are going to lead into the lab, the actual lab. So we'll go ahead and go back. And then you're going to go to the lab instructions right here. And I did edit this document. So I edited it to what I thought would be correct because this document was a little wonky when I inherited this class. Okay, so again, you're going to read the instructions. You can read this on your own time. Right here is the most important. When you do your scale model, when you do this lab, you are going to pick one of these. You can do both, but you're not going to get extra points for it. So just do yourself a favor and try to enjoy your summer a little bit more and just pick one, because in the directions it says one of the following. So when you make your scale model, you're either going to focus on the sizes of each planet or the distances between each planet and the sun. So either size or distance, pick one. Part A is distances. So if you pick distances, number 2, then you're going to, well, you have to fill this out first. And then you're going to go right to part A. And then you do all of the questions in part A if you pick the distance from the sun, distances from the sun. If you decide to do sizes of each planet, you're going to scroll all the way down to part B, called object sizes. And you're going to fill in this table, do as the directions say, read the directions thoroughly. Most of the questions that I've had students ask before have been on the lab. So please read the lab. Like I said, I won't be able to answer your questions right away. Normally I'm able to when I am back in Maryland. However, I'm not. So try to use some common sense here and, you know, use context clues to figure out what the question is asking you. And if you don't know what context clues are, then Google. Okay, cool. Sorry, I will be drinking water frequently. It is the desert and I am on a mountain very high in the sky, so lots of water. Okay, so let's just say we pick distances. Great. And if you see like your group or go to the quad at HCC, obviously that is not possible. Obviously. So ignore it. Just be like, it's just you. It's just you. If you have a friend that you wants to help you with this, by all means, sure. You can't copy them. You can't have them do your work. But if you need help doing something, absolutely you can use them. Or if you have a kid, use that. Okay, so you will be looking up various values such as planet diameters or distances from the sun. And you will do this online on Google. Google's a great resource. Depending on where you look, you might find it given in miles or kilometers. Please put it in metric units. So America uses imperial units, so that's miles, inches, feet. We're not using that in this class. You must convert imperial American units to metric units. You must. It is not a question. You have to do dimensional analysis to convert from one to the other. And you need to show your work. You don't have to show your work in this table, but in these questions below, you must provide your work, all of your work. If you just put an answer, I will mark it wrong. You have to show your work. So you will do dimensional analysis for most of these questions. We should decide as a class what units we're going to use. Metric. So all of your sizes and distance in this lab, you're going to put here metric units. That's what I decide. Like I said, I did not write this lab, I just edited it, but definitely put metric here, just because. I recommend also printing this out and filling it in like that. If you don't want to do that, you can just download this document and fill it in as you need. Cool. Make sure that if you fill in this, like if you write words here, it's going to leave like blank spaces, like the line isn't going to completely fill the word if you type it in. Please don't let the lines go below. Like, okay, never mind. It looks unprofessional and sloppy. So just delete some of the line if your words are not in the lines. Cool. Okay, then you're going to fill out this chart. You're going to look up how far each planet is from the sun. Okay, so what is the distance between Mercury and the sun? What is the distance between Pluto and the sun? Fill that out. So you're going to put that here. And then you're going to figure out the scaled distance. But you have to do the distance first. So you have to fill out this column. Okay. And depending on what website you use, it will say miles. You can put the miles value, but make sure you also give the kilometer value as well. You need to choose a scale factor for your scale model. A scale factor is something like 1 centimeter is equal to a kilometer in real solar system. You can do that. You can also try something like 1 centimeter is equal to 2 million kilometers. Because if you use this conversion, it's not going to be, I mean, it's going to be correct in terms of like math, but like you can't actually measure that. You know what I mean? Like you would take up a mile or two of land doing this scale. So make sure that you do something like 1 centimeter is equal to 2 million kilometers. So that way 1 centimeter, you can fit it on a regular piece of paper or a couple of pieces of paper. You can like tape them, whatever you want to do. You're going to choose a scale that will allow you to mark off scaled distances on the quad sidewalk. You're not going to be on the quad sidewalk. You're going to be taping like pieces of paper together. You want a scale that makes the smallest distances large enough to be drawn, and large distances small enough to fit into whatever you do. So maybe instead of 1 centimeter is 2 million kilometers, you could say 1 centimeter is 5 million kilometers. Whatever you want to do, but make sure it's a large number of kilometers, because you're going to be modeling huge, massive distances, and you need to make that scale a lot smaller and something that you can actually work with. Cool. You're going to write down your scale that you used. And I said here, make sure that if you do decide to do it in chalk, take a picture, but make sure that you are in a safe, COVID-friendly place. That means not COVID, like that doesn't mean like go to somewhere where COVID is relevant, but go to somewhere that you can go where you aren't going to be surrounded by people. Keep yourself safe. Hence, use your common sense, okay? Please follow CDC guidelines if you do go outside. Okay, for number 3, basically what you're gonna do here is just write out all of your work. I suggest that you handwrite it. That is going to be easier for me to read. So handwrite it. You can also handwrite it on a piece of like scrap paper or something, or notebook paper, and then take a picture of it and put that picture in for number 3. Make sure that your picture does not take up a whole page. Let's be real here. Let's not be lazy. Let's make sure that our image that you take is scaled to something that's like reasonable, like a reasonable size picture that allows me to see all of your work. Cool. Right here, this is dimensional analysis. Like I said before, if you don't know what that is, it's basically just saying like, how do I convert 25 inches into kilometers? Or how do I convert 1,000,000 feet into meters? That is dimensional analysis. And you just do a little table thing and cross cancel the units, and then whatever units you want, that's what you keep. If you don't know how to do dimensional analysis, there are many YouTube videos online that you can use that are way more helpful than what I would do. Basically, your units are going to cancel and you should get something like kilometers. Fill in the scaled distance from the sun column in the table above. You're just going to fill in the table. Okay. Number 5, make sure that you just read the directions right here and fill it in as best as you can. Then for the next part, you are going to read the short story, and it's located past part B and C right here. And it's page 6 and 7. Cool. So that is that. Number 7, what is beyond Pluto but still part of our solar system? Interesting. If you read this, you'll probably be able to answer that question. Make sure that when you measure stuff, you also convert, like for right here, like you can use astronomical units. And if you pay attention to the lecture, you should know what an astronomical unit is. If you don't though, an astronomical unit is basically the distance from Earth to the sun. And that's about how many miles? I want you to think about that. If you don't know, that's okay. Anyway, it's probably about 9 million miles. And actually, wait. Is it 9? You should look it up and do research too. So 1 AU is equal to, I have so many numbers in my head, I completely forget. Yep, it's about 92 million miles, 93 million. About 93 million miles. So the 9 was right. It's just way more than 9 million. It's 93 million miles. Cool. That is one astronomical unit. Make sure that you use the full number. It's 92,958 miles. Convert miles into kilometers. Okay, and then you're going to use this website to answer this question below. Great. So if you decided to choose object sizes, you're going to basically kind of do what the distance people used, except you're going to just read the questions and do it a little bit differently. So what's different here? Let's see, number 2, I would recommend saying that 1 centimeter is 2,000 kilometers. So you could use that as a scale. I'd recommend using that. So whenever you go to do the scale using, most people don't have butcher paper, by the way. So just use like regular printer paper or scrap paper or like notebook paper. It's fine. You can tape them together or just sit them side by side on your floor. It's fine. Not a big deal. Make sure you take a picture of it. I would like to see that. If you don't, I'd be sad and maybe take off points. We'll see how many people actually do it. Anyway, that's how you're going to make your scale. So that's how you're going to do the objects. So don't make a literal scale model of the sun. That will take up way too much paper. Just for the sun, just do a strip of paper that represents the diameter of the sun. We don't want to be wasteful here. Let's not cut out a big circle of the sun. Just give me the diameter, and that will be fine enough for the scale. Okay. For number 3, again, just like in part A, you're going to use dimensional analysis here. You're going to write out the math and cross cancel those units until you get the unit that you would like. So preferably kilometers. Again, fill out the scale right here. Fill out this column for number 4. Number 5, just answer this. Now part C, everybody does this. However, for number 1, if you did part A, you will do number 1. So that's Pluto and Sun. If you did part B, you will do number 2. Don't do both, because unless you did both. So if you did part A, do number 1. If you did part B, do number 2. If you didn't do one or the other, don't do the other, one or the other. Then you are going to answer, actually no. So number 3, unless you do both of them and you're just bored in the summer, you don't have to do number 3. But I did leave the question here just in case somebody wanted to do both things and compare. Usually this makes a lot more sense if we were in a classroom and we had lab partners and stuff. Okay, that's cool. Basically what number 3 is saying is it feasible to use the same scale factor for object sizes and object distances? Should we use the same scale factor? And I'll answer this for you since we're not going to really do it. Basically, planet distance values are much greater. So the distance between each planet is much greater than the size of a planet, right? Like obviously, so let's say Earth was 6,000 miles in diameter. I think that's the circumference, but let's just say that's what Earth was. And then we say the distance from Earth to the sun, that's 93 million miles. Obviously, the distance, like the diameter, the size of the planet is a lot less than the distance between each planet. So it's kind of an obvious thing, but it is kind of confusing if you kind of don't know what this question is asking. If you try using planet diameters, the scale factor for that, for distances, you're going to get crazy huge distances. So don't do that. Yeah. All right. That really just concludes this lab. Make sure that you read this. I'm not going to read this for you. You can do that on your own time. If anybody has any questions, make sure that you email me, even if it's a small question. But before you email me, make sure that you have looked at all of the possible resources on the Canvas page. So don't ask me a question like, oh, what's the name of the lab? Where do I find it? No, you need to look. You need to make sure that you've exhausted all of your possible things before you ask me a question. Like I said, I would recommend asking like an important question because like I said, I don't have a lot of time. Normally I would answer within a couple minutes of receiving an email or a text, but because I'm up here in a mountain, Wi-Fi is spotty, service is spotty, I will not be able to answer them right away like I normally do. Also, I will be teaching little kids, so but definitely within 24 hours, like I said, I will get back to you. So don't worry about that. So make sure that you do your lab sooner rather than later. So don't wait till the last minute to do this lab, because if you do have a question, I will not be able to answer in time. If you do need extra help and you'd like to schedule an appointment with me to meet up in Zoom, we can totally do that. Just let me know, email me, and we can set one up. I do have off time in the evenings over here, which kind of doesn't align with East Coast and West Coast time zones, but I will try my best. If you want to meet in the morning, let me know if that's better for you. Anyway, I hope that you guys have a great summer, and I hope that you learned a lot about astronomy. So thank you, and I will see you later. I will see you next week in a video.